and today we're going to be talking about atoms. An atom contains protons, neutrons and electrons. And protons and neutrons are in the nucleus while the electrons are quite far away. But if an electron's here around a proton, then it could also be here and here and here and here and here and everywhere else in the universe. And also it could be, if an electron was here, it could also be nowhere. And if an electron was here, it could be here. And even it could be in the proton as well. And that's quite cool. The nucleus is held together by the strong interaction and the weak interaction, which keeps the nucleus together. And that's also why I can't just fall through this tube and fall through the earth and then go out the other side. A hydrogen atom is 10 to the power negative 12 meters. Atoms are also mostly empty space, but they're not. The empty space between the protons and electrons are filled with quantum fluctuations. If a hydrogen atom was the size of my house, then the nucleus would be the size of a grain of sand. And the electrons would be specks of dust. And that's insanely small. So back to the atoms. There is 118 of them. The smallest element is hydrogen, and then it would go to helium, and then to lithium. And you may think it would go to 1 proton, 2 protons, 2 neutrons, and then 3 protons, 3 neutrons. But it actually goes 3 protons and 4 neutrons. And then on boron, there would be 10 in total, 5 protons, 5 neutrons. Carbon, 6 protons, 6 neutrons. I'm just going to say these are all the pure elements. There are different isotopes of them, but these are the pure ones. But after carbon, there's nitrogen, 14, oxygen, 16, fluorine, 19, neon, 20. And there's a group called the noble gases, which literally, the top one, helium, never, ever, ever reacts with anything. Okay, it can react with something if it's in an isotope, but in pure helium, it can't react with anything. And also, if you think I'm sitting on this chair nice and comfortably right now, then I'm actually floating just this tiny, 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 tiny distance. And this table is floating and that piece of paper over there is floating. Because the electrons, okay, a proton and electron like each other. But an electron and electron don't. They push away each other because they're both negative. Unless it's a positron, which they do want to go together and annihilate each other into energy. And even if you had 2 immensely powerful electrons, they would literally never touch. It's the repulsion. That's why we feel things. That's why those spikes now, those spikes feel uncomfortable when you touch them. If you cut something, the atoms don't split in half, even though if you want them to, they still can't. The electrons of the knife push them apart so that it looks like they're cutting, but the knife never actually touches it. Bye, see you again for another video.